For centuries, the soybean has been cultivated and used for food by people in the Orient. The soybean belongs to the same family of plants as do our common beans and peas. This Chinese farmer finds that his crop of beans is of a fine quality and ready for harvesting. There will be enough for his own family and some left to sell. The cultivation of soybeans was begun extensively in the United States about 1918. Since that time, it has been studied intensively by agronomists in several agricultural experiment stations. Experiments are carried on in small plots of soybeans to discover the best varieties of the hundreds known and the best methods of cultivation. Trained observers watch the plants in all the stages of their growth to see if the beans have desirable characteristics. This soil expert, Dr. Blake, is particularly interested in the soybean as a means of conserving the fertility of the soil. If used correctly, the soybean is a good soil builder. Like most legume plants, the soybean has the power of using the nitrogen in the air, provided the roots are well nodulated. These nodules contain bacteria, and it is these which convert the nitrogen of the air into a form that the plant can use. For this reason, the soybean is a valuable plant in crop rotation and soil conservation. These nitrogen-fixing bacteria may be grown in laboratories. These cabinets assure the proper temperature for growth. The tiny bacteria grow on a jelly medium which supplies them with the necessary nourishment. These bacteria are sometimes mixed with peat before they are marketed. The farmer may mix the peat-containing bacteria with water and inoculate the seed by spraying. Then he mixes the seeds thoroughly and lets them dry. The agronomist keeps in very close touch with the actual work of the farmer. For this reason, he makes frequent visits to nearby farms. As the agronomist drives along the country road, he observes this field of corn, which might have been better if soybeans had been used in a good crop rotation.
Good morning, Mrs. Hill.
Good morning, Dr. Blake. Do you remember that sample of edible soybeans that you gave me last fall?
Yes?
This is our first mess.
I'm glad that they turned out so well. Where can I find Bill this morning?
I think he's mowing in the bean field, about a half a mile down the road.
Thank you. Goodbye.
Goodbye.
As Dr. Blake is driving past Mr. Hill's fields, he notices this fine growth of corn, due largely to a rotation including soybeans. Mr. Hill is cutting these soybeans for hay, which he will feed to his cattle and horses during the winter months.
How's it going, Bill?
Fair. The dew is a little bit heavy this morning, but the sun has dried it out now. It looks to me like a pretty good crop.
I'd say you'd cut it at just the right time. If you had waited much longer, I'm afraid that the hay would have become stemmy and lost some of the leaves.
Yes, and I hope that I can get it in before we have any more rain. Have you noticed my field of beans on the South 40?
I saw your bean crop a couple of weeks ago. It looked promising then.
Yes, they'll be ready for the combine in another month.
A few weeks later, we find Mr. Hill harvesting his soybeans with a modern combine like that used for wheat and oats. The combine has done much to make the soybean a popular crop. The beans are cut and threshed all in one operation. The straw, containing much nitrogen, is scattered back on the land as fertilizer. When the hopper gets full, the beans are run into a waiting truck. The beans now start on their way to the local grain elevator. From here, they are shipped by train to a processing plant in a nearby city. First, the soybeans are cracked. The cracked beans are fed to these expellers after they have been heated in these steam pipes to about 200 degrees. The cracked soybeans then enter these cylinders and are subjected to a pressure of about 16,000 pounds per square inch. The great pressure, with the help of the high temperature, forces the oil out of the beans. The oil from all the expellers is next forced through this large filter to remove sediment. The crystal clear oil drips out along the side of the filter. Soybean oil finds extensive use in paints and in the manufacture of linoleum. But most of it is used in making shortenings, oleomargarine, and salad dressing. In the compressor, the soybean cake emerges at the end of the shaft. Much of this cake goes back to the farm where it makes a fine feed for dairy cattle. These steers have made excellent gains on a feed containing soybean meal. Many industrial chemists are working to find new uses for soybean oil and soybean meal. This chemist, Dr. Brother, is striving to improve a process by which the soybean meal is made into a hard and strong plastic. After long and tedious labor in the research laboratory, he may discover new procedures or new products which the engineering chemist can put into large-scale production. The chemist pours the soybean meal into this mechanical mixer. Then it is transferred to these rollers, which mix the soybean meal with the other ingredients that go into the manufacture of plastics. Before casting the mixture into a plastic, the chemist tests it in this machine, which is called a flow tester. This curve indicates the plasticity of the mixture or dough under increasing pressure. The chemist also inspects the piece, but he uses asbestos gloves because the pressure has made it hot. Having passed the test, the mixture is reduced to a powder and poured into this mold, which will determine the shape of the finished object. The mold is then placed in this hydraulic press. Here, the soybean meal is welded under a pressure of about 2,000 pounds per square inch and at a temperature of more than 300 degrees. In this way, the soybean is transformed by science and technology into parts that find many everyday uses. In research laboratories, the finished plastic products are subjected to innumerable tests. This flexural testing machine reveals the strength of the object. Thus, we are led to appreciate the relationship of modern science to agriculture on the one hand and industry to agriculture on the other. The agronomist strives to increase land productivity, while the chemist works to find new industrial uses for the products of the farm.